Hello everyone and welcome to second part of PyTorch 101 series, the second video. And in this video we are going to discuss what Autograd in PyTorch is. So don't worry about Autograd if you don't understand it right now. It's super useful, but since it's in the backend, you will probably not interact with it that much. So what Autograd does is it's used in the backpropagation step when training your neural network. So you have to calculate the gradients of error with respect to all different parameters, and that's what Autograd is doing. So I'm just going to give an intro to Autograd. So it can be best understood by an example. Autograd is an automatic differentiation engine in PyTorch. So let's try. Let's import torch, and we define two variables. One is torch.tensor a. This is a float, and then we say require grad to true. So we just need to set this. And then we have b. Let's say it's 6. Requires grad to true. So we got a, we got b. Requires grad is set to true for both. And we define a y as a cube minus b square, let's say. So y is 89, and now you see it as a grad function, which is sub backward 0. So grad function associated with y. So now if you remember from your high school mathematics, you have to calculate. So y is, let's say, my error or loss. So I have to calculate dy del y by del a and del y by del b. So these will be my gradients of a and b, right? So if I do it by hand, dy by dA will be, or del y by del a will be 3 multiplied by a square, 3a square, right? And this is 3 into 5 square, and 5 square is 25. So this is 75. And dy by db, del y by del b is 2b, minus 2b. And that equals to 6. B is 6, so this is minus 12. Okay, so now using Autograd we can compute this automatically. So how to do that? It's very easy. So first we check a.grad, and it doesn't return anything because it's none. And similarly b.grad will also be none in the beginning. So what we do is we do y dot backwards. Okay. Sorry. Always confused. So if we do y dot backward, now we have a value of a dot grad, which is 75 as we calculated, and b dot grad, which is minus 12. So this is way to calculate gradients using Autograd in PyTorch, and this is more useful when it comes to creating your own model. So where you have let's say you define a weight vector, weight matrix, and a bias vector. So you can do torch dot rand n 10, 1 generate a random vector, matrix, requires grad equal to true. And similarly you have simple bias, so let's just say 1 and b. It's very simple. And you have the weight matrix, here in this case it's just a vector, and you have some features x. So torch.rand 1,10. So you have some features, one sample, and what you do is like a simple linear regression. So torch.matmul x, w plus b. So this will be your output, and now you calculate loss. So loss is, I don't know, let's say 1 minus output. This is your loss, and if you print loss, it has a grad function associated with it. If you print output, it also has a grad function associated with it. So here x doesn't change, w and b are your parameters of the model. And now what you do, if you're not familiar with what I'm doing here, I would totally recommend you to do the Intro to Neural Networks lecture by Andrew Yang. It's very simple, and that's one of the best lectures. So now what I do is I will do loss.backward, and now I have w.grad, a value, and b, that's -1. Okay, and now we update the weights, right? So if we update the weights, we do w equal to w plus w minus learning rate multiplied by w.grad.data. We do this. So now here I don't want to calculate the gradients, I just want to update. So what I do is I use with torch.no_grad. So it just temporarily sets the value of requires grad to false for all the parameters inside this, and I update the value of w. So yeah, learning rate is not defined, let's put it 0.001, and here I have the new w. So in each iteration I will need to clear the gradients and update the weights and biases. So this is what we are doing, update the parameters in each iteration. And before starting the iteration, before you do loss.backward, you need to set the gradients to 0 or none, and that's usually done by optimizers in Torch, and we will see that in next lectures. So that's it for Autograd. It's a very simple, very gentle introduction to Autograd, and we will now take a look at different kinds of dataset classes, or what is a dataset class in PyTorch. See you.